That's good, Mike. Cool, thank you. Welcome everyone. First and foremost, apologies for the delay. We've had some technical issues, but good news, we have overcome those. First and foremost, thank you everyone for coming to today's session for the supplier briefing on residential space and water heating technology studies. Before we start, we'll just introduce the people from EECA's side. So my name is Brad McMeekin. I'm a lead procurement advisor here at EECA, and I'll be kind of chairing the session today and passing it around with my colleagues. Yasmin?
Hi, I'm Yasmin. I am the procurement coordinator and I'm here just to support.
Kia ora, ko Andrew Tapuingoa. I am the manager of our research team here at EECA, largely just sitting in to hear what's covered.
Oh, and I'm Michael Houlihan. I'm just IT.
Lovely, thank you everyone. Vince, would you like to go next? You need to unmute, Vince.
Yeah, I'm sorry.
Just fine.
Hi all, I'm Vince Smart. I'm lead advisor in the REI team at EECA.
Lovely, thank you, Vince. Tim, last but not least.
Hi everyone, my name is Tim Cruncher. I'm a senior advisor in the Research Evaluation and Insights team, and I'm managing this project.
Lovely, thank you everyone. Before we get underway, we'll just tackle a bit of housekeeping. So the purpose of today's session is to provide you an overview of the published procurement, provide details on the requirements in the procurement, and also answer any questions that you may have with regards to the requirements and the procurement on the whole. This session is not for proposing an alternative approach or increase in scope. We'll just be tackling the content of the RFP. The session will be capped at 60 minutes. I acknowledge we started late by about 10 minutes, and Tim will run you through a brief agenda shortly. The discussion that we have today will have no impact on how you will be scored at all. And we'll also publish a Q&A and the video of this session on Gets as well, so you can have a look at it later should you need to. All information relating to suppliers, certainly questions, will be anonymised. You'll also see us taking notes as we go through the session. That's so we can reflect on the conversation afterwards. These notes won't leave the group and will be disposed of accordingly. So with that in mind, I will throw you over to Tim, who has a presentation on the tender and the requirements. Tim, would you like to get underway?
I think he might be muted to, not sure,
Yeah.
Centralized or on your own PC, sorry.
How about now?
Perfect.
Great, sorry about that. Okay, so here's the agenda for today. First up, we'll discuss the purpose of the study and what we hope to achieve. We'll then chat a bit about some of the pre-tender engagement that we conducted prior to the RFP. Then overview the RFP itself, including the requirements, and finally, time for Q&A. So this is a study which is a little bit novel, and it is relatively complex. We have a combination of different techniques here required to address the scope, and we haven't seen any prior research along these lines in the New Zealand context. So we anticipate it to be a good challenge. This is our overriding objective here. EECA's purpose is to mobilise New Zealanders to be world leaders in clean and clever energy use. So this is definitely driving this work, and something that we would like the results of the study to affect. So to drill down into a little more detail, Part of EECA's role is to provide advice to residential consumers about their energy use and carbon footprints, and this is in line with some strategic objectives, energy efficiency first, and also empowering energy users. So the purpose of the study, the goal is to explore how life cycle carbon emissions vary across different residential space and water heating technologies, and really drilling down into the specifics of the use case. We're primarily considering or comparing resistance heating versus heat pumps here. Both electrified options. And we are wanting to explore this across various contexts representing New Zealand's residential diversity of housing and energy use patterns. So a goal sitting below this is we would like to use residential space and water heating as really a case study to investigate these underlying relationships between cost, efficiency, life cycle carbon, and cumulative energy demand. So this project is intended to be in support of various EECA programs. Warmer Kiwi Homes is an obvious one where we are interested in this trade-off between active and passive space heating options. Will also likely inform the E3 equipment energy efficiency program and minimum energy performance standards associated with this. This is quite topical in the sense that it's alongside an increasing focus on home electrification and hot water heat pumps in particular. And generally, this project is intended to bolster EECA's role as an authority in this space. So a little bit more about the segment that we're targeting here. This chart shows a breakdown of final energy consumption by sector. And we can see here we're focusing on residential heating. So this highlighted segment. This is approximately 10% of total final energy consumption. And if we drill down a bit further, we can see how this has evolved over time. So looking here on the right at the residential sector, the two bar segments at the bottom, low temperature heat for space and water heating is what we're interested in. So this segment, you can see it has been growing slightly, and it's approximately 50% of total home energy consumption. So it's reasonably significant in that sense, although within the bigger picture, each of these segments is only approximately 4% of total final energy consumption. But it is one of the areas where we see a potential for behavioural interventions and shifting use patterns. So a little bit more about the space and water heating options. So the default position that EECA is taking is that heat pumps are typically the more efficient, typically the best option. However, we are looking to introduce some nuance into this discussion, and primarily that's around the wide diversity of both the use cases and household types, and also the various installations, the various technologies and how they can be installed in the home. There are a number of other issues that are relevant here. So refrigerants is one that we're interested in, and the global warming potential associated with refrigerant losses. Also key to this particular research project, the question of embodied emissions in those technologies and the capital costs. Also variability in the operational lifetimes of the various equipment, maintenance requirements that they might have, and also implications for peak demand and controllability of those assets. And this is all against the backdrop of a rising renewable share in the supply mix and widespread anticipated electrification of homes and businesses. So it's within a relatively dynamic moving picture of the New Zealand energy system. I should note here that we're also interested in technologies that can supply both space and water heating. These energy service categories are often considered separately, but there are systems such as underfloor hydronic that can address both, potentially with greater efficiencies. So this drives a research question for this project of what available space and water heating technologies should households select to minimize the lifetime carbon emissions? So a little bit about the pre-tender engagement. We conducted this with a cross-section of suppliers in the market in late 2023 and early this year. And this was undertaken at a relatively early stage while the study was still being conceived. So this engagement, the primary reason for this was to refine the project scope and to develop our own thinking in the space. And the requirements in the published RFP are EECA's own requirements. Okay, moving on. So the RFP itself. So what we're seeking, what we require is essentially lifecycle analysis, and in particular in compliance with ISO 14067. So focusing on energy and carbon emissions in particular. And we're wanting to calculate cradle to grave emissions and cumulative energy demand associated with the annual supply of space and water heating. So to do this, there are several components here that will need to be addressed. One is a material inventory, or a set of inventories describing typical space and water heating installations in New Zealand. And we're interested here in space and water heating energy service categories separately, and also the potential for a combined category there. And we do want to consider the ancillary hardware that would be required for demand response that's expected in the coming years. So specifically AS/NZS 4755 compliant. So the analysis here covers quite a different range of temporal scales, everything from annual down to hourly, a range of end user and system variables that I'll discuss in the next slide, and also some specific risk factors. So we want to use a scenario or case study based approach here. Particularly, we're interested in taking in an all of system perspective. And by this, we mean we want to consider the role of the changes in the time of use profile and the associated requirements for network capacity that this drives. And this is a trickier point where maybe this study diverges from some prior work. So I'll expand on that a little bit more later in the presentation. And these outputs from the study we hope to be suitable for informing case-specific decarbonisation options for New Zealand households. So to do this, to pull this off, we're looking for suppliers experienced in LCA primarily, but also either directly or through suitable subcontractors with expertise in space and water heating technologies and energy systems analysis. And also obviously the interest and capacity to carry out this work together. EECA intends to be relatively involved in the methodological choices. And so we're looking for a collaborative partner to carry out this work. So some of the inputs, key inputs and variables. Well, mainly to describe the use case, we're looking at a series of variables here. So the dwelling type, insulation level, heating schedule, occupancy, and climate zone. We're looking at likely 4 climate zones in this study, but that's yet to be determined. And here's an example of a dwelling type that we would consider. We have modeled residential thermal demand data for 4 housing types and variations across all of the other variables. So please note that we're not requiring modeling of the thermal envelope of homes in the study. That data, that work has already been completed and will be provided to the successful respondent. So this connection between storage and network capacity. So this is one aspect of the study that we think is quite interesting and we've chosen to focus in on. And for this reason, we would like to treat storage capacity associated with any given space and hot water heating installation as an independent variable where that makes sense, and vary this in order to look at changes in the time of use profile. And at a minimum, we'd want to consider the difference between seasons and also on-peak versus off-peak demand. And then in conjunction with this, this will require a forecast of both network and generation build. And from this, we will calculate not only the direct emissions or the typical B6 component of an LCA, the operational energy use, the emissions associated with that, but also this broader boundary, embodied emissions from incremental changes in transmission and distribution capacity. So essentially an analysis of peak demand here and the embodied emissions that can be attributed to a given household user. We understand that it won't be possible to carry out an exhaustive LCA or a detailed study for this second component here. So we will require some form of simplified estimation method. There are examples out there in the literature. There's one listed, a master's thesis listed at the bottom of the page here, but this is certainly not the only one. And we are open to varying levels of detail in this estimation, as long as the associated uncertainties are propagated through to sensitivity analysis, which I'll discuss soon. So alongside this work, there's various other pieces to flesh out to complete the project. First would be following the calculation of life cycle emissions of the various technologies, the identification of optimal combinations of those technologies for each combination of end-use parameters. So for each end-use case type, essentially, each household type, which are the combination of technologies that minimize life cycle emissions. We're also interested in equipment lifetime. So we would want to some extent, investigate whether this is better modeled as a function of utilization or perhaps just simply elapsed time. And also considering some particular environments which may affect this, such as coastal regions, and flagging those where necessary. And then finally, sensitivity analysis of the key outputs, primarily life cycle carbon, to uncertainties that we can identify, generally associated with quality and completeness of some of the available data, how suitable that data is in the New Zealand context, for example, any adjustments made. Also, variability in refrigerant losses, variability in equipment lifetimes relating to the above point. And finally, given the uncertainty involved, a plausible range of future emissions intensities for electricity supply and also associated network build in New Zealand over the relevant time frame for the equipment we're looking into. Okay, so finally, here are the evaluation criteria that we have. So we're focusing here on the quality of the proposed solution, whether it's fit for purpose, transparency around key uncertainties and risks and mitigation of those risks, and the suitability of the proposed deliverables. Secondly, capability, so experience of personnel and any demonstration of the technical and market knowledge that you may have. And in particular, these three areas of life cycle analysis, building services, and residential space and hot water technologies. And finally, broader energy systems analysis. Capacity, so we'd like to see previous or current examples of similar work, a breakdown of the work proposed, an organization, an overview or structure of your organization, and the feasibility of the timeline. The proposed timeline is something that we will be looking at, including mitigation of any issues regarding the timeline. And also your proposed work arrangements for collaboratively working with us. Then on broader outcomes, so we're looking here at government broader outcomes, for example, engaging with Māori and Pacifica businesses and reducing emissions. And finally, public value, or the competitiveness of your estimated total cost. Okay, that's it. So we're now at the point for questions. So I think we can open the floor. Brad, did we want to start with anything in the Q&A? I don't see anything there currently.
Yeah, so to ask a question, you go to the QA tab and you should be able to start a discussion, ask a question, and yeah, post it through there and we should get it on our end.
And also to that point, no two questions are the same. We'll endeavour to answer them now, but if we can't and we need to find the information from somewhere else, we will be publishing a Q&A also as well. So we will provide the answers for you. So we have a question here. Is there a page limit for proposals? Unless otherwise addressed in the procurement plan, in the RFP. No, there is not. We do hope that it's just proportionate to your solution and provides the information needed for us to conduct an evaluation. So the next one might be for you, Tim or Vince. So we just had a question here, which asks us, do you already have a list of technologies you want to explore, or will defining the list be part of the exercise?
Good question. So defining the list will be one of the first steps in the project. We do have some relevant binaries that we're interested in regarding those technologies, and we'll be looking at coming up with a list of specific installations on the order of 5 or 6, but it will depend on the complexity of the analysis and the proposed methodology. So that will be one of the initial tasks.
We have another question, Tim, Vince. So has any consideration been made for evaluating the LCA associated with cooling solutions when paired with resistive heating?
So for this particular study, we're looking at space and water heating only, and we're aware that some of the equipment can also be used for space cooling. However, that's out of scope for this particular study.
So I'll take the next one. So we have a question here with regards to, is EECA open to compromise on research requirements, i.e. The amount of scenarios in order to match the indicated budget? Based on the scope of the RFP, it would be difficult to deliver all of the proposal at the given budget. We'll see this. The published requirements in the tender are final. We won't be changing those. We just ask that you put together your proposed solution that meets those requirements at a price as well that you can deliver those requirements with. We have another question here. So how are you planning to engage with Māori in this project? That's a good question. Broader outcomes is certainly a weighted criteria in this procurement. We ask suppliers submitting a response if they have any capacity to engage directly with Māori throughout their supply chains, or if they have any other avenues they wish to explore with their solution. Does anyone else have any further questions? We'll just give it a couple more minutes and see if anything flows through. So we have another question here, Tim, Vince. With respect to the report deliverable, does this need to be an ISO 14067 compliant report, or would the report need to be peer reviewed?
So we are looking for the analysis to be compliant with 14067, and that, as we understand, will require a peer review from a single peer reviewer, and we have factored that into the expected timeline for the contract of approximately 9 months.
We have another question. What is the scope of the supporting infrastructure, e.g. concrete, building materials, etc.?
That's something that's yet to be determined, although we would likely want to take a relatively broad boundary there. Obviously, there's somewhat a reduction in uncertainty when we broaden those boundaries and consider those associated building materials with the typical installation. And we might also want to look at the difference between a retrofit versus a new build, but that is all yet to be determined and will depend on available resource and cost.
We have another question. Do you have any information regarding the heat pumps and heating brands models most commonly installed in New Zealand?
Not at present. It will likely be one of the first steps of the project to determine data requirements, and EECA is prepared to help with data procurement, but we don't have anything concrete so far, except for the modeled thermal demand data that I mentioned.
Just to add to that, I mean, for products that are regulated by MEPS, the minimum energy performance standards, we do collect sales data. At this stage, that's not a full set of the types of the technologies that might be covered in the study. So there's some data on things like residential space heating heat pumps, but yeah, it's unlikely to be a complete set. And there are restrictions as to what we can do with that. So we'd have to be careful to anonymize it, that sort of thing.
Thank you, Vince. We have another question. So we've been asked, are we responsible, is EECA responsible for sourcing the peer reviewer, or is that reviewer to be selected by EECA?
EECA would not be responsible for the selection of that peer reviewer. So we would anticipate that as LCA experts, the successful respondent will have a clearer view of the requirements of that process and any potential reviewers that could be used.
We have another question. Can we reformat the RFP response with our own organisational branding? The answer is yes. We ask that you keep the same flow and heading to the documents so the evaluators can distinguish the information. Otherwise, happy to receive it with branding on it also. Awesome. We have another question. So embodied energy and carbon in building network capacity will vary greatly depending on the assumptions used in any demand model. What level of uncertainty is EECA expecting for this part of the analysis?
So for this, we do anticipate that this will be one of the main areas of uncertainty, and we're looking simply for an honest assessment of that uncertainty associated with the method proposed, and we're less concerned about that being highly accurate, more concerned that the uncertainties are estimated and fed through to the sensitivity analysis. So that's why we have included those aspects in the sensitivity, and would simply like to see the implications of that uncertainty.
We have another question also. So how many dwelling types is EECA proposing?
So we have model thermal demand data for 4 dwelling types, representing 4 different eras of New Zealand's housing stock, and taken together, these represent the majority of the current New Zealand housing stock. So we have 4 housing topologies.
Thank you, Tim. We'll put through one last call for questions. So if anyone would like to ask anything else, now is your chance. Just give it a couple of minutes. Okay, so nothing's come through, so we might hang on. Just as I said that. Another question, are we also considering geographic location for these dwellings?
Tim, your microphone's muted.
Oh, sorry about that. So yes, we are. One of the in-use variables is climate zone. So we have modeled data for 4 climate zones for corresponding to Auckland, Wellington, Christchurch, and Queenstown. We don't necessarily have to use all 4, but they are available.
We have another question. Rather than include scenarios for occupancy and insulation, would it be acceptable to correlate a heating profile with these?
I don't see why not. We're open to a range of different methodologies there, as long as it fully addresses the requirements.
Lovely. So if there is no more questions, we might conclude there. Just as a reminder, the deadline for questions outside of this forum is 5 p.m, the 27th of the 6th, 2024. So you can ask questions via GETS right up until that time and date. The deadline for responses to this RFP is 10 a.m, the 3rd of the 7th, 2024. And the EECA team will be looking to commence evaluations soon after, around the 8th of the 7th, 2024. From there, it'll be a standard procurement process, and we'll look to move to contracting as soon as practicable. Thank you very much for your time today. We certainly appreciate your participation. Thanks again.